Hooray! I have the keys to unlock Pocket Ronnie.
Okay, we're solving for the unknown today. In all of these equations we are doing, you will only have one unknown. In this one, 3b4, we have one unknown. The unknown is q. So we are going to solve for q. In the world of algebra, you treat the equal sign as a pivoting point, and you can think of everything else as a seesaw. And you are trying to balance this equation like it was a seesaw. So whatever you do to this side of the seesaw or this side of the equation, you have to do to this side of the seesaw or this side of the equation in order to make it balance. So whatever you do to one side, you have to do to the other side in order for it to balance. So when you're solving for the unknown, my recommendation is to get letters on one side of the equal sign and whole numbers to the other side of the equal sign. You still have to think about PEMDAS and order of operations. We want to simplify everything and combine like terms before we start moving everything around, okay? So on the right side, I want to combine my whole numbers, and so PEMDAS, I have to do multiplication first. So this becomes 7 plus 4 times 10, which is 40. Okay, let's combine stuff on our left side. You can rearrange everything if you want to write all your Q's together. I'm not going to. The one thing I want to remind you of is the numbers in front of your letters are called coefficients. So what coefficient is in front of this Q? It is an implied 1. In this case, you have a negative, so it would be like a negative 1. If you want to write down a 1 there to remind you, then that's okay. So here I have 8Q. Remember, when you have addition and subtraction, you do it left to right. So I'm going to start from the left and work my way to the right. So I have 8Q minus 1Q, which I now have 7Q. 8 cookies minus 1 cookie, 7 cookies. But instead of cookies, I have Q's. So 8Q minus 1Q is 7Q. Go over to my next Q, minus 3Q. So remember that was 7Q minus 3Q is now 4Q. So I have 4 Q's left. I got that from my Q's. All of these Q's came out to 4Q. Okay, so I took care of my Q's. Now I'm going to take care of my whole numbers. A positive 7 minus 4 leaves me a positive 3. So this is what I have left on the left side of the equal sign. I'm going to just rewrite that closer to this other side. 4Q plus 3. Alright, so now it's just I'm going to combine this on the right side. So I have 4Q plus 3 equals 40 plus 7, or 7 plus 40, 47. Okay, now I want to get letters on the left side and whole numbers on the right side. So that means I need to get rid of this whole number. I need to move it over here with the 47. So in order to get rid of it on the left side, if I have a positive 3, I need to subtract 3. That means I now have 0. But whenever I do the left side, I have to do the same thing on the right side in order to make the equation balance. So if I subtract 3 over here, I have to subtract 3 over there. So a positive 3 and a negative 3, that's 0. And the only thing I'm left with over here is 4Q. 47 minus 3, 44. Now I need to get rid of the 4 because the idea is to get Q all by itself. I'm trying to solve for Q, which means I want Q all by itself. What does 4Q imply? 4Q implies multiplication. That means 4 times Q. So I need to do exactly the opposite of that. If I am multiplying 4Q, or 4 to Q, I need to do the opposite of multiplication. What's the opposite of multiplication in math? It's division. So if 4 is being multiplied to the Q, I need to divide it to get it to go away. Because now 4 divided by 4 is 1. Whatever I do to the left side, I have to also do to the right side. So if I divide this side by 4, I also need to divide the right side by 4 in order for the equation to balance. 4 divided by 4 is just 1. So you can write 1Q, or you can just write Q. Now 44 divided by 4 is 11. So we solve for Q to solve that Q equals 11. Now you can go back and check your answers. How you check is you go back to the original problem, and everywhere you see a Q, you put in 11. So everywhere that you see a Q, you go back in and put and 11 in there, and your left side should equal your right side. I'm going to erase all this work here so I can do my checking when I check. So I said that when I check, everywhere I see a Q, I'm going to put in an 11. This implies 8 times Q. So I will say 8 times 11 minus 1 times 11 plus 7 minus 4 minus 3 times 11 equals 7 plus 4 times 10. That was my original problem. Now I have to do order of operations. I have to do PEMDAS. I don't have any, I have these as parentheses, but that implies multiplication. So I don't have any parentheses or exponents, but I do have some multiplication. So I'm going to go through and do all my multiplication first. 8 times 11, 88, minus 1 times 11, that would be a negative 11, plus 7, I'm not going to combine my plus 7 minus 4. You have to do addition and subtraction from left to right. A negative 3 times a positive 11 is a negative 33. I'm going to combine this, do multiplication first. 4 times 10 is 40, plus 7, 47. So now I need to see if my left side equals 47. If the left side equals the right side, then this was the correct solution. So I only have addition and subtraction left, so I do it from left to right. 88 minus 11, 77, plus 7 minus 4 minus 33. Okay, 77 plus 7, 84 minus 4 minus 33 equals 47. 84 minus 4 was 80. So that would be 80 minus 33 equals 47. 80 minus 33, and that will be 47. So it turns out that 47 equals 47, so this checks. I usually put a check, which tells me that Q equals 11 is the right solution. Okay, let's go down here to 3D6. We are solving for X. Okay, remember the idea is to get letters on one side, whole numbers on the other side. I usually put all my variables, the letters are your variable, they are the unknown. I usually put those on my left side, but it doesn't have to be that way. You can put them on the right. So there's nothing I can combine on the left side. I can't combine x's to 8s. I can't combine x's to negative 2. So the left side and the right side are as simplified as it can be. Because I recommend simplify everything you can on the left side, then simplify everything you can on the right side. Once you do that, now it's time to move letters to one side and whole numbers to the other side. So I want to get rid of this 2x over here and move it to the left side. Well, I've got a negative 2x. Well, I need to do the opposite of subtracting 2x. The opposite of subtracting is adding 2x. If I am in debt 2x, now I'm adding 2x, I'm now at 0. Whatever I do to one side to the equation, I have to do the other side. So if I add a 2x over here, I have to add a 2x over here, and I'm going to write it to where all my x's are lined up. So these go away and are 0. So now 3x plus 2x is 5x, and then I'm just going to rewrite my 8, and then this became 0, so the only thing I'm left with on the right is negative 2. Now I want to get my whole number over here with this whole number, so that way I just have letters over here and then whole numbers over here. So if I'm adding 8, I need to do the opposite of adding 8, which is subtracting 8. And that becomes 0. Well, if I subtract 8 from the left side, I have to do it to the right side in order for it to balance. So that becomes 0, and I'm left with 5x. I'm in debt 2. I'm in debt 8 more. That means I'm in debt 10. Okay, now I need to get rid of this 5. How do I do that? The 5 is being multiplied to the x. So I need to do exactly the opposite of multiplication, which is division. So I divide the 5. If I divide it over here, I have to divide it over here. 5 divided by 5 is 1, which leaves me a 1x, or I can just say x. A negative divided by a positive is a negative. So now I'm going to have a negative number, and 10 divided by 5 is 2. So x turns out to be negative 2. Now I can check it. To go back and check it, I go back and put in everywhere I see an x, I go and put in a negative 2 in the original problem. So I'm going to check over here to the side. So my original problem was 3 times x, and now x is negative 2 plus 8 equals -2 times -2 minus 2. You have to keep up with all the negative signs. Doing multiplication first, a positive times a negative is a negative, and that would be -6 plus 8 equals a negative times a negative is a positive, that would be +4 minus 2. -6, I'm in debt 6. Somebody gives me $8, I now have a positive $2. 4 minus 2 is 2. It checks, which tells me the solution I got is correct. If you come over here and it does not check, either your calculations went wrong in your checking, or your solution that you came up with is not correct. Okay, let's look at 3D8. We have Z. This is my Z, this is my 2. My Z's have a line through them. Z plus 8 equals 2Z plus 18. We don't have anything to simplify on the left. I cannot combine Z's to 8. I do not have anything to simplify or combine on the right. I cannot combine Z's to 18. So now I'm ready to move letters to one side and whole numbers to the other side. So I'm going to move my 2Z over here with this Z. This Z is being added. That's a positive 2Z. So in order for it to be 0, and I need to subtract 2Z. So if I subtract 2Z from this side of the equation, I have to do it to the other side. So I have to do a minus 2Z. This becomes 0 here. A Z, which is that's a 1 in front of it. 1Z minus 2Z is a -1Z plus 8. And there was only 18 left on the other side. Now I want to get my 8 over with the 18. So if I'm adding 8 to get rid of it, I need to subtract 8. If I subtract 8 from the left side, I have to subtract 8 from the right side. This becomes 0. I have -1Z on the left, and then 18 minus 8 would be a positive 10. Okay, so on the left side, I have -1Z left, and on the right side, I had 18 minus 8, which is 10. And so, but the one thing I want to point out, if you don't have that 1 here, you still have a negative. You cannot leave a negative in front of your variable because you're trying to get that variable all by itself without any negatives in front. So this -1 is being multiplied to your Z. So you need to do the opposite of multiplication, which is division. So if there's a -1 there, you need to divide by -1. If you divide by -1 on the left, you have to divide by -1 on the right. A negative divided by a negative is a positive. 1 divided by 1 is just 1. So -1 divided by -1 is a positive 1, which leaves you a positive Z. Over here, a positive divided by a negative is a negative, and 10 divided by 1 is just 10. Whenever you divide both sides by -1, it just changes the sign of each side. So it turns out Z equals -10. Now to check, you would need to take, everywhere you see a Z, you would take this and you put in -10 and see if the left side equals the right side. So putting in -10 in for Z, you'd have 1 times -10 plus 8 equals 2 times -10 plus 18. 1 times -10, a positive times a negative is a negative, and 1 times 10 is just 10, plus 8. 2 times -10, -20, plus 18. -10 plus 8, I'm in debt 10. Someone gives me $8, I'm still in debt $2. I'm in debt 20, someone gives me $18, I'm still in debt $2. So this does check, which tells us that the solution I got of Z equals -10 is correct.